Lesson 9H, Work Energy Example. A 57 kilogram cart is pushed from rest with a force of 94 newtons for 8.4 meters. The coefficient of friction is 0.12. Here's a picture of the problem. How much work is done in pushing the cart? How much work was done against friction? How much work was done against inertia? And finally, what is the final velocity of the cart? Part A, how much work was done in pushing the cart? Total work is simply the applied force times displacement, W equals Fd. Total work is 94 times 8.4, which makes 789.6 Newton meters, or 789.6 joules. With sig figs, it's 790 joules. Remember, the total work done was work done against gravity, not in this example since it was pushed along a horizontal surface, against friction, the resistive force of objects touching that opposes motion, and against inertia, the property of matter that Newton's first law is based upon. It states that objects at rest want to remain at rest, and objects in uniform motion want to remain at uniform motion, unless an unbalanced force acts on them. Part B, how much work was done against friction? Work against friction can be calculated again with force friction times displacement, or W equals F times D. The formula for friction force is mu mg, so work against friction becomes mu mg times displacement. Work against friction is 0.12 times 57 times 9.8 times 8.4, which is 67 times 8.4. That makes 563 Newton meters, or 563 joules. Part C, what was work done against inertia? This can be solved in two ways. First, by using net forces. The force applied to the object was used to overcome two forces, force friction and force inertia, which we call F net. Force gravity is the third force that work is used to overcome, but does not apply to this example since the object is not hanging, nor is it being lifted. This means that F net, which is applied force minus friction force, is the force used to overcome inertia. F net is 94 minus 67. F net is 27 newtons. Using the work equation, W equals Fd, work against inertia is 27 times 8.4, which is 227 Newton meters, or 227 joules. We can also solve for work against inertia by using the law of conservation of energy in a closed system. Total work was calculated earlier as 790 joules. Of that total, 563 joules was used against friction, leaving the work remaining to overcome inertia as total work minus work against friction. That's 790 minus 563. Work against inertia by the applied force is 227 joules, which is the same value calculated using net forces from the last slide. D. What is the final velocity of the cart? Using our work energy principle, we know that work equals change in kinetic energy. In this case, not all of the work was used to accelerate the object. Only the work against inertia accelerated the object. The other 563 joules was against friction. So work against inertia is final kinetic energy minus initial kinetic energy. Initial kinetic energy is 0 since the object began from rest. Work against inertia is half mass times final velocity squared. Subbing in our values, we have 227 joules equals half 57 times final velocity squared. Isolating final velocity, we have Vf squared equal to 2 times 227 divided by 57. V sub f squared is 7.96. The final velocity is 2.8 meters per second forwards.